Here we go. So I entitled today's lesson, excuse me, entitled today's lesson, Common Core Catch-Up. And what I did was I made these lesson plans a couple of years ago. And each year I've tweaked them a little bit. Try to get them to do a better job as we learn more and more of exactly what the Common Core expects. But the Common Core asks questions in a different sort of way. And it's not that they're any harder, they're just different. So I want to go through a couple of examples of that today rather than forge ahead with new material. So we're going to do this lesson today, and all it's going to do is take stuff we already know and kind of just change our understandings of it a little bit. And given the fact that it seems to be a Monday and you guys seem to be just a little bit off your game, maybe this is a very well-timed lesson. So, when you multiply two terms by two terms, you get four terms. Now, two terms by two terms is like a binomial times a binomial. Why is the final result when you multiply two binomials sometimes only three terms? Give an example of how you could end up with two terms. So, let's say I did x plus 5 times x plus 4. And let's see what it works out to. If I double distribute here, it's x times x, which is x squared. Then the x gets times multiplied by the 4, which is 4x. Then 5 times x is 5x, and 5 times 4 is 20. So at first it looks like it's four terms, which is what they're talking about. But what happens that it's not four terms? You can combine like terms in the middle. Very good. So it becomes x squared plus 9x plus 20. Now, the reason that the terms in the middle are combinable is because they're kind of similar binomials, Sam. I have an x plus 5 and an x plus 4. If I ever did something like this, x plus 3 times a plus b, I would get four different terms and I would not be able to combine them. It's only when they're kind of similar things like an x plus 5 and an x plus 4 that they'll work out to be combined. But then it asks an interesting question. It says, can you come up with only two terms? Did anybody play with that and only get two terms? It is possible.
Yeah.
Well, you're going to need to get a 0 in the middle. I don't know if you meant that or not. Let's try this one. Instead of x plus 5 times x plus 4, let's try x plus 5 times x minus 5. X times x is x squared. X times negative 5 is minus 5x. 5 times x is positive 5x. See what's going to happen? What are they up to? Nothing, right? So I get x squared minus 25. And it only works when these two numbers are the same, with opposite signs, one positive, one negative. But that'll only work if these numbers are the same here, and one's positive and one's negative. So that's the only way to get down to two terms. Other than that, you cannot get to two terms. Okay? So, I think when you first read the question, and you probably felt like this, you're like, what the heck are you talking about? I have no idea what this question's trying to get to. But then when you do it, I think you look at it and go, that's it? It's really not hard at all. And one of my impressions of the Common Core is exactly that. That some of the stuff is very hard, but some of the stuff is not very difficult at all. It's just understanding what they want to get to and what they want to get at, okay? Any questions? All right, so let's have you try this question about Jacob here. He lives on a street that runs east and west. The grocery store is to the east, and the post office is to the west. Both are on the same street as his house. Answer the questions below about the following story, okay? And when you draw a graph, it's a sketch. It's not like a super accurate graph or anything like that. So play around with that for a few minutes, think about it, and I'd say give you about 2 minutes, 2.5 minutes, and then I'll get up and I'll put it on the board for you. It may help you to know that rate times time is distance. Hopefully you remember that. So let's give it a shot and see what we're looking at here. Again, very strange sort of question. You wouldn't expect it in math almost. Jacob lives on a street that runs east and west. The grocery store is to the east and the post office is to the west. So, let's see here. Here's the street. Here's Jeremy's house. And it says here, grocery store is to the east. Post office is to the west. Okay? Jacob hops in his car and drives at a constant speed of 25 miles an hour for 6 minutes to the post office. After 10 minutes at the post office, he realizes he is late, and he drives a constant 30 miles per hour to the grocery store, arriving at 1:28 p.m. He then spends 20 minutes buying groceries. Okay, so draw a graph that shows distance Jacob cars from the house with respect to time. So here's time, here's distance. So the bottom line is he starts here, and he's going to go 25 miles an hour for 6 minutes. So if I just let this be 6, and if he goes 25 miles an hour for 6 minutes, let's see, what kind of distance does that cover? 25 miles an hour for 6 minutes. So rate times time is equal to distance, 25 miles per hour. Now here's the catch. You ready? 6 minutes is what part of an hour? 1/10, right? So I have to do that times 1/10. And that would give me 2.5 miles. So, after 6 minutes, if this is 1, 2, 3, 4, 5, 6, we're at 2.5 after 6 minutes. And it's a constant rate, so that means it's a straight line. Then he drives 30 miles per hour to, oh, wait, doesn't he say he waits there or something like that? After 10 minutes at the post office, so I'll go to 10 here. So he's the same distance from home, he hasn't moved, right? What's that? What?
Yeah.
Wait, so I don't, oh, we started at 1 o'clock, and then he drives for 6 minutes to the post office, so it's 1:16. And then it says, after 10 minutes at the post office. This is minutes, this isn't time. This would be 1 o'clock, 1:06, 1:16. But it's 6 minutes from when he left, and then it's 10 more minutes from, 16, is that what you were saying? Okay, all right. So then we're at 16 there, and then it says, drives 30 miles an hour to the grocery store, arriving at 1:28 p.m. So, again, rate times time is distance. He drives 30 miles an hour, and this time he drives for, how long here? Arrives at 1:28, so that's 12 minutes. 12 minutes is what part of an hour? 1/5, right? So how far does he go altogether? 5 goes into 60, 30 how many times? 6. So he goes a total of 6 more miles, so if I'm at 2.5, I'm gonna go up to 8.5. Why would that jump so much? Boy, is that strange or what? Well, I did it for a little bit longer and stuff. Okay, so here's my graph up till there, and then it says he stays there for what, 20 minutes? So this would be another, how many minutes he goes? At 1:28, which is 12 more minutes, and then he stays there for 20 minutes, so it's 32. I know the graph should have been done in a little bit of a bigger space. All right, so bottom line is he drives for a little while at a certain set speed, which is 25 miles per hour. Then he goes for 10 minutes and does nothing. Then he drives at a faster rate of speed, which means that the slope is greater because the rate of change is greater. And that speed would be 30 miles per hour. And then up here at the top, he just kind of hangs out for 20 minutes. Okay? Questions? Piecewise graph it is. Now, let's have you try these two. Go ahead. We'll go over them in 2 minutes. Okay, Sam, highly mathematical. so. Okay. Find two consecutive integers such that the sum of 3 times the first and the second is 41. So I'm going to let this be, come on, let's go. What's going on? If the pen doesn't behave, treat it like a teenager. Smack it around a little. Oh yeah, I'll straighten the pen out every time. Just like a teenager.
Okay.
First consecutive integer. Second consecutive integer. Now, what is the first integer? Call it x, next one x plus 1. 3 times the first, that would be 3x. And the second, that would be x plus 1. And that gets me 41. Altogether, I have 4 x's. Plus 1 is 41. Minus the 1, 4x is 40. Dividing by 4, x is 10. Is that the answer? Oh, I thought I wrote it. X is 10. What are the two? Did I answer the question? No. 10 and 11. Sweet. Okay, find the slope and the y-intercept. Got to get y by itself. Minus 7x. 3y less than negative 7x plus 12. Divide by 3. Y less than negative 7/3 x plus 4. Okay, what's the slope? Hello? Guys, what's the slope here? What? Negative 7/3. What is the y-intercept? 4. Broken or solid? Broken. How do you know it's broken? That's right. And would you shade above or below? Below. Because there's less than. If there's a sign at the ride, and you want to get on a ride at the amusement park, and it says you have to be greater than 48 inches tall, are you above the line or below the line? Above. If you're less than it, you are below. Okay.